All right. Oops. Sorry, I'm not going to make that mistake again. So, yep, I'm done sleeping. I just snapped awake at like 2 a.m. and can't get back to bed. So, worst thing you can do in that case is just lay in bed and associate the bedroom with not being able to sleep. So, anytime you're not sleeping in the bedroom, you should get up and do something else. So, we're going to make another video here. We're on to a more interesting section to software-defined access design. Kind of that's a huge buzzword in networking is software-defined. Um, so in the last video, we went over these two designs. This one we didn't have a lot of problems with. But we forgot to test the failover capability, so that might have been problematic. This one here, we actually had packet loss, 1 out of every 5 frames. We saw that the traffic went down 1 link, but it went back up across 2 links. And not only that, when we tested high availability by shutting down one of the distribution switches, the traffic never reconverged. So high availability just did not work. So big problems there that I would like to try to resolve, but in the interest of getting through this whole guide, you can see we're about at the 1/4 mark, and we're already at video number 9 or number 10. So we're just going to move on from those problems and start reading the next section. Another way to overcome the layer 2 adjacency restrictions while still maintaining the advantages of the routed access layer design is by adding fabric capability to a layer 3 access campus network design, supporting an overlay network with the required layer 2 connectivity. The benefits of Cisco SD access technology are the coupling of the layer 2/layer 3 forwarding plane of the endpoint/user from the overlay network, the unification of wired and wireless policies, and the advantage of not having to hairpin wireless traffic to an overlay node such as WLC, wireless LAN controllers. The addition of the fabric overlay is automated using Cisco DNA Center to deploy Cisco SD Access technology. The Cisco SD Access design enables the use of virtual networks, overlay networks, or macro segmentation running on a physical network, underlay network, in order to create alternative topologies to connect devices. So here we have kind of similar to what we had before. We had, looks like we have 3 uh, tiers, core, distribution, access, but the difference is now we've got an extra tier here, the shared services distribution tier, which is stacked. Um, and then we've got a wireless LAN controller on that. So overlay and underlay connectivity. So I guess I'm not sure what kind of device this is here. It's a different graphic than these other ones. So I'm guessing it's a different kind of device. And it looks like it's a stackwise virtual. I'm not sure what that means. So really confused about this. I wish they would be more clear and put it in different terms. So let's keep reading. Perhaps I haven't gotten all of the information yet. Beyond traditional network virtualization, Cisco SD Access allows for software-defined segmentation and policy enforcement based on user identity and group membership, integrated with Cisco TrustSec technology to support group-based micro-segmentation policies. Beyond support for the wireless LAN, and unlike any alternative virtualization technology, Cisco SD Access also inherently supports integration of the wireless LAN for a common policy across the entire campus domain. For additional information, see the Software Designed Access Solution Design Guide. So this is definitely something we're going to be doing at some point, looking at different design guides. Um, But for now, we're just going to continue with this main guide here. So I guess my takeaway from this section is just that if you want to get into it and actually set this lab up and play around with it hands-on, which we will want to do eventually, the right time to do that is when you're reading this guide. So I'm going to skip the hands-on for this because we're going to need a more robust and detailed guide in order to get through that and understand what that shared services distribution stack-wise virtual device is for. Understand the difference between an overlay and underlay network, and learn about SD access fabric. It's got its own guide, so we're going to skip it, the hands-on, and move on to the next section, which is alternative virtualization design for campus using BGP, EVPN, and VXLAN. For organizations not requiring the full automation and assurance support for macro and micro segmentation policies integrated with wireless across the campus LAN, there are alternative multi-vendor options available. Traditionally, the multi-protocol label switching (MPLS) technology or basic segmentation for VRF Lite has been adapted to wireless networks to attempt to replicate service provider like segmentation within the LAN. Recent standards body work has proposed an alternative means to support Ethernet VPN, EVPN overlays in the campus, and like Cisco SD Access, has the option to use VXLAN encapsulation. Unlike Cisco SD Access, the control plane protocol for creating forwarding tables is BGP and scales using the well-known concept of route reflectors. However, EVPN does require greater access, leaf, and border forwarding table scale due to the nature of the multi-protocol BGP MPBGP control plane. Okay, so we've got our external networks. Now we've got a fabric border leaf. We've got distribution. Then we've got our route reflectors here. And we've got BGP EVPN fabric. For organizations looking for an open standards-based overlay solution for their campus designs and not needing the full intent-based networking security solution along with integrated wireless, BGP, EVPN, VXLAN can be a viable alternative to traditional campus virtualization options. Okay, so I'm not sure what a overlay solution is, and I'm not sure what the alternative of that is. Um, I'm not sure if an underlay is alternative or it's something else. I kind of want to skip this hands-on as well, um, because this is I think also software design. Let's see if this will show up in this guide. Okay. All right. I don't see anything in the guide. Okay, so we've got this SDX Central, and we've got the question we're looking for. What is overlay networking? Perfect. Or an SDN overlay. Overlay networking, aka SDN overlay, is a method of using software to create layers of network abstraction that can be used to run multiple separate, discrete, virtualized network layers on top of the physical network, often providing new applications or security benefits. Created by taking two endpoints and creating a virtual connection between them, multiple secure overlays can be built using software over existing networking hardware infrastructure. These endpoints could be actual physical locations, such as a network port, or they could be logical locations designated by a software address in the networking cloud. The virtual connection between two endpoints of a network is created using routing or switching software that can apply software tags, labels, and/or encryption to create a virtual tunnel that runs through the network. If encryption is used, the data can be secured between the endpoints so that the end users must be authenticated in order to use the connection. One way to think of the technology is to think of it as endpoints designated by an identification tag or number, somewhat like the phone system. A device can be located simply by knowing its identification tag or number in the networking system. These tags are used to create virtual connections. Okay, so let's read the key takeaways and then move on. Key takeaway number one, an overlay network is the use of software to create layers of network abstraction to run multiple separate, discrete virtualized network layers on top of the physical network. Number two, the virtual connections on an overlay network are created using routing or switching software that applies software tags, labels, and encryption to create a virtual tunnel connecting to the network. And number three, the encoding of traffic to travel over the virtual network overlay requires computing power that can pose scalability issues. Okay, so I guess SD-WAN doesn't scale? That's not good. Okay, so let's just move on. We won't need to set this up, I think. Um, yeah, so I hate to kind of move on from this because it seems like a pretty big thing, but I'm just not sure how far I'll get with this in the lab. The last one took a long time. I don't know if I have the devices for this. I guess the Junipers could probably do it. Uh, but I think we're going to move on. The goal of this particular video is to read this design guide, not necessarily to be able to implement every single aspect of it. Design fundamentals, LAN security best practices. With any good network design, security must also be a focus. These tools below can help prevent attacks and make the network more secure and reliable. These are a few fundamental tools to help with basic network security. Check out the Enterprise Security Design Guide for a more in-depth look at campus security. And it looks like there's no link, but we will check that out right now. Here we go, design code for security. All right, so I'm not sure what happened to that, but let's learn about DHP snooping. Rogue DHCP servers can be detrimental to the security and usability of the network if not protected against properly. Rogue DHCP servers attack the network by assigning unroutable IP addresses to clients, causing them to lose connectivity. Also, rogue DHCP servers can be used to issue malicious DNS servers. Users can then looking to go to real websites. Oh, users then looking to go to real websites will be sent to fake copies of these sites to steal credentials or information. DHCP snooping is a tool used to combat rogue DHCP servers. It works by assigning one or more ports as trusted, meaning these ports lead to legitimate DHCP servers. The switch will then build a database of the untrusted hosts with leased IP addresses, MAC addresses, switch port, and VLAN. Traffic being sent from these untrusted hosts will be filtered of any DHCP server messages, blocking any attempt of a malicious DHCP server. Okay, so we might skip that again. You know what? I kind of don't want to skip it, so let's not skip it. Let's try to set it up. DHCP snooping in the lab. So let's do DHCP snooping. Okay, so basically, all you do is you set up DHCP snooping on all ports in your network, except the port that has your DHCP server on it. Um, yeah, right. Yeah, that's kind of where I'm at. I understand the general concepts of DHCP, but the details, especially when it comes to how DHCP is implemented differently in different vendors, are a bit beyond me. And that actually really perfectly kind of sums up the recent realization I've had that certs really aren't enough. They're a good starting point, but they really don't give you enough knowledge to be successful at a really high level. And I learned that recently, and it's been kind of a shock to me to learn that. Um, and this really gives a good explanation for why that is the case. In most certifications, I'm sure there are some exceptions, they're tied to a vendor, so you really work only learning about a specific implementation of a protocol on a specific vendor. And not only that, most certifications, even to some extent the CCIE, the expert level certifications, really are just a lot of different concepts um, at some level of depth. So it's really not a deep dive into one concept the way uh, it in you know the CCIE is perhaps that expert level are perhaps getting there, but even on that, I'm sure um, in some sense it is more general. So. Yeah, and this has an RFC attached to it, so that would be good. Let's see what kind. So it's in the standards track. Yeah, this would be absolutely perfect to read. That would be amazing. Okay, I think I'm on the right track though, to get to the next level in network engineering, reading this design guide, reading the RFCs, labbing. I think that's the way to go for now. I think I am planning to recert, but certs I'm realizing really aren't enough. They're just a starting point. They're just a place to begin when it comes to really, really high level knowledge in networking. Certifications are not where it ends. Certifications are where it begins. Okay, so let's set up DHCP snooping on all ports except the port where we have a DHCP server. And before we do that, let's set up VLAN 40 again and test that other solution. That should be pretty fast to set up, and we'll see if we have packet loss with that, and we'll see if we have failover. If we have those two things, we're going to be all set to use that for our design. Otherwise, we might need to kind of do some more thinking and come up with a design that actually works before moving on to this. Okay, so let's open up both access as well, because we'll change the name of the VLANs from both to left and right. Okay, so leg 1 goes to the left, leg 2 goes to the right. So let's add a description to that to make things easier. Okay, that looks good. And then we need VLAN 40 to go to the right now. So we got to change that on our leg 2. And we're going to use trunk ports now. Or we can just keep using access ports. That'll be fine. Oh, right. And we don't need these VLAN interfaces anymore because we're just doing regular old layer 2 all the way from here to here. We have one giant layer 2 broadcast domain with no chance of loops because we've got a line topology. Okay, but we're going to be changing that. We're going to have two different segments. Oh, never mind. Okay, one thing to note when I say 30 here, I'm not actually this is just a this is hexadecimal. So if I wanted to actually do 30, you wouldn't put 30 in there. It's kind of escaping me a little bit exactly what it would be. Um, okay, so now we need interface 40. Okay, that looks good to me. Um, yep, and we've got 30 and 40 like that, left and right. So let's do the same thing on the distribution. Okay, so on here, leg 1 is going to the right, and then leg 2 is going to the left. And that should match what we've got on the other one. But of course, we're going to need VLAN 40. Okay, yeah, it looks good to me. Perfect. Oops, so never mind here. We've got a description here that doesn't work. We've got VLAN 30 going to the right and VLAN 40 going to the left. That's not going to work. But it looks like the only problem is our descriptions. So we'll change those. Okay, so now we've got 30 to the left and the leg number matches across the chassis. Same with the right. Okay, so now we're going to need our virtual interfaces or our SVIs. .3/17. Okay, so we've got everything good to go now. We need to make some changes on the access layer as well, but we only need to change one side here. But we'll change both just to change the name of that VLAN. Go above and beyond. Okay, we're no longer going to have. Oh, we are still going to have our group as well, um, but we'll add. Uh, yep, and then we're going to have untagged for everything. Okay, so now we've got to do right 40. Oops, we got to do a. Actually, we don't need a tag. We can have it untagged. Maybe that's the problem I had before, is since it was untagged and I used a tagged here, there were problems. So let's try it like this, where we actually don't have a tag set up because they're untagged anyway, so we shouldn't need one. Looks good to me. So let's enable DHCP snooping. Okay, we'll look for that. Um, okay, so we need our upstream ports to be trusted, but um, uh, okay, so I think he's got it wrong here. Looks like this was 2 years ago, but I guess I can reply to him right now, to David. So it looks like he's enabling DHCP snooping on everything, but and then on the uplink he's not. But I think you also need to um, because well, actually maybe not because maybe it's just ingress traffic. So egress from this, you might, and in fact, it's probably better to have that because that's where the attack. might occur. So let's try this. Okay, so I don't have the ability to set the VLAN here. Okay, I'm not sure if I read this section yet. I don't remember it if I did, so I'm just going to read it again. If I did, or I'll read it for the first time if I did not. Rogue DHCP servers can be detrimental to the security and usability of the network if not protected against properly. Rogue DHCP servers attack the network by assigning unrunnable IP addresses to clients, causing them to lose connectivity. Also, rogue DHCP servers can be used to issue malicious DNS servers. Users then looking to go to real websites will be sent to fake copies of these sites to steal credentials or information. Dhp Snooping is a tool used to combat rogue DHCP servers. It works by assigning one or more ports as trusted, meaning these ports lead to legitimate DHCP servers. The switch will then build a database of the untrusted hosts with leased IP addresses, MAC address, switch port, and VLAN. Traffic being sent from these untrusted hosts will be filtered of any DHCP server messages, blocking any attempt to a malicious DHCP server. So I'll move my highlight down there. Um, it did sound familiar. I think I did read that already. So we got to do enable. Okay, so enable IP security, DHCP snooping for left 30. Ports all violation action. We're going to drop the packet. And then we'll just send a SNMP trap. Looks good to me. Now we need trusted. Trusted ports. So we're going to have our uplink ports be trusted. So that's port 1, which is our LACP port channel. We're going to trust it for a DHCP server. There we go. And now we got to choose which DHCP server we're going to trust. Okay, so now we can choose if we want it to be on the .0 or to the .128 subnet. Let's do it on the .0. So we'll give it 192.168.100.100. Okay, and we're going to trust this for a DHCP server. Okay, I think that's everything. Okay, and we're going to use the same IP here to trust. IP source addresses are preserved after they're routed, unlike MAC addresses, so I think that's going to work. Hopefully, we'll see. Okay, and now hopefully it's a bit easier on the distribution switches. Okay, and now we're going to add an authorized server. Okay, I think that's all we need here, so it is quite a bit easier, but unfortunately we don't have the option to do it for ports, just by IP, and then we don't have the option to take a specific action. I mean, I'm sure we do, but I don't know how to do it. All right, so let's go over to our PCs, and we're going to set up. So we're going to need, the other thing we're going to need is a helper address on VLAN 40 DHCP helper address because it's not on the same broadcast domain. Okay, so we've got to figure out what our helper is. Our helper is going to be the default, so the helper is unicast or broadcast IPv4 address. So there we go. Actually, I think the helper is actually going to be the address of the server itself. And not only that, this IP is clearly a typo, so we'll fix that. Go, and then we're going to do the server itself, and not the default gateway of it. There we go. All right, so everything's good to go. Let's plug in our DHCP server. Actually, before we do that, let's set these to DHCP. Okay, so can't find the server. That makes sense because we don't have it set up yet. So let's set it up. We'll do a new template, see if we've got a, we can just use a regular Ubuntu server, but let's see if we can get something specifically for DHCP. So we got something specifically for DNS. We've got an F5 load balancer here, but we don't have something specifically for um, DHCP. All right, that's okay though. We'll just use an Ubuntu box for that for all of our stuff, and we'll set up syslogging as well. So let's use just the regular, just the full Ubuntu server here. Okay, and we can set up bonding on it. Remember, we're using a topology that actually looks like this. So if we set up bonding, we can see that's going to be what makes the most sense in that type of uh, topology. Okay, so we don't have, looks like we don't have a, oh, we do. Oh, no. Yeah, we need a DHCP server. So we need access to the outside world. So let's set that up. Now I think the best way to set it up would be to plug it into the distribution layer. Um, but let's just take the easy way for now. Might change it later. I'm kind of tempted to just use a Docker container. Might be a bit faster. But what's nice about this is I can just Google init. Okay, so we've got the outside world. Well, I forgot to update. There we go. Hmm. Hmm. Okay. Oh no, I know what I'm doing now. Um, yeah. So I also need to set up bonding. So, well, and I might need to. This might be it for me. And then of course I need to configure the distribution port as well. Okay, so let's try using the mod probe command. Oh, so it looks like the driver isn't loaded. We didn't get anything. So let's install the package. Okay, we're going to need to clean up this command. Okay, so let's see what we got. We've got ENS5. Do we have any more? ENS4. So I think ENS5 is the one to the cloud. Yeah. Oh, well, that says ENS2. ENS0, 1, and 2. Okay, so the two lower number, ES3 and 4, we want to the bond. 5, yep, and it's got an IP to the outside IP to my internal network. So we just want 3 and 4. Looks good to me. Oh, yeah, it's not ETH, it's ENS. Okay. I don't get it. I just don't get it. I mean, the object I want is a link, right? Ah, got it, finally. There we go. Okay, so now we've got ENS3 belonging to bond 0, 4 to bond 0, and in addition to that, we've got bond 0. Bond 0 is down. These are up though, but it's going to be down until we configure the uh, inner ports here. So let's do that right now. Okay, we opened it twice. We don't need it opened twice. Oh my God. So we don't have LLDP. Let's see how to set up LLDP on Ubuntu. So it looks like we might have to install it. There we go. So now we've got LLDP set up. So hopefully it shows up. Doesn't show up, but that's probably because we don't have those ports configured yet. So I've got to remember which one it's connected to. Yep, we have the port administratively down, so we're not going to get L to P on that until it comes up. So it's going to be port 3 on both of them. Okay, and we're going to do another leg. Okay, and then we got to set up the other side as well. Okay, so now we should be getting LDP. Don't have it. Ah, now we have it. Perfect. So, yep. Okay, so now if I do IPDHCP, hopefully I can get one. Oh, didn't configure the actual DHCP server yet, so we're going to need to do that. Oh, it looks like we do have it. So let's modify the config file. There we go. Okay. Okay, so we gotta declare our subnets here. Okay, let's uncomment. No! Oh no. I did all that. Okay, well, we'll just copy it. There we go. And then we'll do enter. Oh my god, that happens so often to me. Oh, this has to be 127 here instead of 255. Okay, looks good to me. I think we gotta do a sudo though, just to be. I think that's what. No. Okay, so that should be good. Let's see if we can pull an IP now. Can't. Can't do S. Let's see if we can ping the. Oh, you know what? I think that's it. If I do a ifconfig, um, bond zero. First of all, what happened to our bond zero? It looks like it went away randomly. Um, is it in IPA? It is in IPA. Oh, okay, because it's down, it's not going to show up in IP config. So let's do sudo um, uh, IP bond zero. Sorry, help. Oh, IP address bond zero or help. Yeah. Yep, and then we'll do add. Oh, first we do the address and then we do 192.168.100.100.10. And can I do a gateway? I can't. So I think we'll just add a route. Oh, you know what? This is probably why. Oh, that wasn't right. I can't share my clipboards. Oh, let me do a sudo. Oh, I did. Okay, perfect. Hmm. No, I forgot the sudo on this. Uh, easy. Oh, I forgot something. Let me add it. Forgot the ENS. Huh. So it looks like it's doing better than it was before. It's at least thinking. Oh, oh my God. What a nightmare. What an absolute nightmare this has been. Yeah, I'm not sure what's going on. I mean, at least I'm getting LLDP now. Still getting LLDP. Ah, so I think it worked. We've got a new interface now, bond 0. Perfect. Let's try pinging our default gateway. Aha! All right, we're good to go. So let's try pulling IP from the DHCP server. Oh my God. Come on, please, please, please. Nothing. Nope. No such luck. Can't find it. Oh. Well, wait a second. Okay, so it's gonna let's look at the so these stands for discover. Let's sniff the network and see if uh, we're getting any discover messages down these links. Okay, so we're not getting any discover over those links. Let's try sniffing some different links. We'll try these links here. Ah, here we go. So now we do have discover traffic going. So it looks like it gets to the distribution layer, but then from there it's got issues. So we can see what the problem is. Here we have the multi-chassis command, but here we do not. So let's try to add that. I have a feeling I'm going to have to tear it down. Yeah, it already exists, so it's got to be torn down. All right, so now we should have better luck. Still no such luck. So it's still down. It's disabled by LACP or lag. Still down. Why is it down? I don't get it. Oh, it was working. What the heck? Yeah, so we can see we did have it working here, but now it's just not working. Destination host unreachable. .3 is working. .2 is working. And it looks like .3 is not working. Yeah, so this is not working. Okay, so the problem is that it's out of sync for LACP. Oh, okay, looks like it's up now. I'm sorry, the port is up, but the leg is down, I think. Yeah, leg is down. Oh, you know what? I think it's because the heartbeat beat rate is different. We've got slow here, but in our bond zero um, interface, we've got fast. Yeah, bond LACP rate fast. So let's try changing that to slow, see if that does it. Um, Looks like I lost my machine here. I can't move my cursor or anything. Let's try changing this side to fast. Hmm. All right, so that didn't do it. So maybe the problem's here because I lost my cursor. So let's try rebooting this. Oh, looks like something happened with my. Oh, it looks like I accidentally tanked this one as well. Yeah. Oh my god, it's not coming up still. That's annoying. Looks like my Ubuntu is still booting up as well. Okay, this video is almost 2 hours now, so I'd like to stop it soon. This is just a total nightmare. Yeah, the other side's still not up. Okay, we'll just try a reboot. Ubuntu server's back up. Looks like dist L is booting now. Oh, okay, dist L crashed. Well, shoot. Looks like dist L just won't work. It keeps crashing for some reason. Just don't get it. I just don't get it. Is bound zero up? It's up. Still down. I don't get it. I just don't get it. I don't understand it at all. Um, Maybe it's because of these other. Default neighbor state. I don't know what that means. Out of sync, default neighbor state. Maybe LACP relies on a VLAN tag, and that's why, because I have untagged, maybe that's why it's not working. No, but I mean, it's for the access layer. Ah, okay. So that was the problem. We had to have LACP fallback configured on one side, otherwise it wouldn't work. We configured it on the left side. I kind of want it on the right side, actually. Um, oh, looks like it's not configured on the right side. Maybe I'll try configuring it on both. Okay, so now it's up. So obviously there was something wrong with LACP. I think it's wrong on the Ubuntu because I'm not able to get it to come up. So now we've got individual default neighbor states. So we just basically don't have LACP uh, on here anymore. But so we've got like a static lag. Okay. All right, now let's try pulling an IP from PC1. Still nothing. Still can't ping from there. All right, we're well over the 2 hour mark now. So I think that's going to be it for me if this doesn't resolve the issue. I'm just not sure what's going on. I mean, I know what's going on. There's a problem building a LACP multi-chassis port channel to the Ubuntu device, um, but I don't know how to fix that. Nothing. Nothing. Oh, here we've got a problem. These are not named properly. Let's rename those. Oh, yeah, here's another problem. Leg 1 needs to go to the right. Yeah. Or wait, never mind. Oh, okay. Yeah, so the leg 1 is fine. It goes to the left. Port 2 goes to the left. Yep. There we go. All right, so again, I have no idea what's going on. I kind of want to remove DHCP snooping from everything, just to see if that'll help. So that's the last thing I'm gonna do, and then I'm gonna move on. I just gotta throw in the towel here. I don't know how to get rid of this one. All right, I guess I'll just leave it. All right, that's going to be the end of the video. Apologize, it was mostly just me trying to hash things out and failing to do so. The final thing I'm going to do is set up static IP on PC1 and PC3, and then see if failover works on this. If that even doesn't work, then um, I'm really kind of upset, but let's give that a shot. Okay, that's normal because maybe it's ARPing. Okay, well, that's not normal. Even that is not working. Okay, so that's frustrating. I'm not sure what's going on there. It's really frustrating. I'm very frustrated. Um, Maybe it's having to do with it being tagged or untagged. Um, I guess I want to check one more time on the access layer to see if I've got that set up, but I have access ports, should be fine. Yeah. Oh, yeah. So I have it here untagged, and I have it here untagged. Um, and then I should have it untagged on these as well. Yeah, access is untagged. Access is untagged. untagged, untagged. Okay, so let's try it trunk and then change it to tagged, and that'll be the last thing I do in this video. So first we're going to change it to tag. Oh, there's no tag. Okay, let's try it like this, untagged, but no, you know what? Let's do a tagged in 30. There we go. Still nothing. Oh, you know what? I've got to have the ports going to the PC untagged. There we go. Now we're talking. Okay, so let's see if the failover works. And now that we have that, let's see if I can do ping to 192.168.100.100. Okay, so we're still having issues with that LACP um, link, but that's okay. Let's see if we've got redundancy. So I'm going to hose one of those devices. Let's start by hosing the one on the left. Okay, so we missed a packet. We had SEQ equaling 46. Aha, but we only miss, oh my God, no. So we've got a problem here. It looks like the problem we had before, every fourth packet or so is now dropped. What the hell is that all about? That's so weird. Um, okay, so let's bring this up and see if that problem resolves. I have no idea what that's all about. It's probably has to do with LACP or something. Like it seems like it's not it seems like it's something wrong with the lag. Like the lag isn't set up properly. Okay, now we've got about every other. Okay, now we've got that Aruba up again, so we've got traffic looking good. Let's try the other one. And I really think the problem with uh, the packet loss we're getting is due to LSCP. Okay, I don't see the anything turning red here, but there we go. Now it's red. Okay, and now we just get zilch from this side. So obviously something is going very, 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 very wrong. And I think it's LACP. This one goes down. We get packet loss every fourth packet or so is successful, but the rest are lost. This goes down. We got nothing at all. So that's obviously not okay. We need to have resiliency. That's the point. So big loss for this video, but unfortunately I've got to end it. We're at the 2:30 mark. So uh, so let me get my like bookmark ready. So when we come back, we'll be looking at dynamic ARP inspection. We might spend some more time trying to get that to work as well because it's just really frustrating that it's not working. Really, really, really frustrating. Oh, okay, so that's going to be the end of part 10. And it looks like in addition to that, even when this one comes back up, unlike the other one, we don't get our pings back. So something horribly wrong is happening. This is completely not the way you want things. Completely bad. So I don't know if I just didn't save my config on that one or what the deal was. Let's take a look. No, I saved everything. So yeah, okay. Unfortunately, yeah, it's just not working, this topology. So we'll spend some more time on that in the last video, but hopefully we can keep reading more of this guide. We still got a lot to go. All right, but that's it for this video. See you in the next one.